In this short video lesson, we're going to cover power. Now, if you remember back from the unit on energy, we defined power as the rate of energy traveling through. In other words, it's energy divided by time. Now, if you look at the units for that, energy is measured in joules, and time is measured in seconds. This is what was known as the watt. Now, if we look at it in terms of this unit, we use joules to measure the potential energy of charges as they're traveling through a circuit. So potential energy per second is another way of writing power. Now, we learned for charges, potential energy is found by taking the charge times the potential difference. So I can rewrite PE over S as Q times delta V over S. Now let's think about this. Q divided by S, charge divided by seconds. What is that? Remember from the last video, that was what current was. And so power can also be rewritten as current times the potential difference or voltage. So we end up getting power can be calculated by taking current times voltage. Now, we also learned in the last chapter, the last video, we learned Ohm's law, and Ohm's law was V equals I times R. We're going to use this to rewrite power, one in terms of I and R, and two in terms of V and R. So let's do the first one. The first one is asking us to rewrite the power equation, which is right here, but only in terms of current and resistance. In other words, it wants us to change the voltage. Okay, remember, voltage is the same thing as current times resistance. And so for this first one, we end up getting power is equal to the current, which is right here. And instead of writing voltage, I'm going to write what voltage is equal to, which is I times R, according to Ohm's law. If I simplify that, that gets me I squared times R. So power can be calculated by doing I squared times R. Let's look at the second one. The second one wants it to be rewritten, but in terms of voltage and resistance. So in other words, we need to get rid of the I. So power is equal to whatever I is, I'm going to leave that blank for a second, times voltage. Now, if I rearrange this, remember I is equal to V over R. So I'm going to put that in here. Instead of putting I in here, I'm going to put V over R. If I take V over R times V, that gets me V squared over R. So power can also be calculated by taking V squared over R. So we now have three equations to calculate power. If you know the current and the voltage, do I times V. If you know the current and the resistance, do I squared times R. If you know the voltage and the resistance, do V squared divided by R. Okay, let's do some practice. A 100-watt light bulb is connected to a 120-volt outlet. Find the resistance. Okay, we know the power. We know the voltage. We want to find the resistance. If I look at those three, I'm going to use this equation here. P equals V squared over R. If I solve for R, that's V squared over P, which comes out to be 120 squared over the power, which is 100 watts. If I do 120 squared and then divided by 100, that gets me 144 ohms as my resistance, which is letter D. All right, let's look at this one. A current of 20 milliamps, so I know my I, flows through a 1500 ohm resistor, so I know my R. Find the power, P. Since I know I and R and I'm wanting to solve for P, I'm going to use the equation P equals I squared times R. My current is 20 milliamps, but it needs to be in amps in order for me to use this equation. So amps would just be moving the decimal 3 places to the left. So 0.020 amps squared times my resistance of 1500 ohms. 0.02 squared times 1500 ends up giving me 0.6 watts is my answer, which is answer C. This concludes the video on power.